Okay, so we have to design some sort of finite state automaton that recognize the language of all strings over the alphabet A, B, and C, with no A's followed by a B, no B's followed by a C, and no C's followed by an A. So the first thing you should do when you see this problem is basically try and work out what information do I need to keep track of while I'm reading the string from left to right. So I'm always going to accept the string unless it violates one of the conditions. And the condition is, if I read the character B, there couldn't have been an A before it. If I read a C, there couldn't have been a B before it. And if I read an A, there couldn't have been a C before it. So basically, I only have to keep track of the last character I saw. So I'll add 3 states. I'll call those states A and B and C to sort of represent the last character that I've seen. And because in the starting state, I haven't seen any characters yet, so I guess I need a 4th state for I haven't seen any characters yet, and that'll be my starting state. So if I see an A, obviously I transition to the A state, and so for B and so for C. And then whenever I see a new character, I'll change the last character that I've seen. So if I'm in state A, and I see an A, then A is still the last character I've seen. If I see a C, then C is the last character that I've seen. And if I see a B, that means an A is followed by a B, so I'll just not add a transition for that, which will make it reject. Similarly for C, if I see more C's, that's okay. If I see a B, that's okay. But if I see an A, that would mean a C is followed by an A, and that's no good. And in this case for B, so read a B. B's can't be followed by C's, but B's can be followed by A's. And I guess we can just make every state an accepting state, which basically means I'm going to accept always, except in the case when I get stuck, which is precisely the case where one of these 3 conditions is violated. So that's my automaton. Is your finite state automaton deterministic, non-deterministic? Explain. In this case here, mine happens to be non-deterministic. Why is that? Because if I'm in state A and I see an A, maybe I should have called them S sub A, but that's okay. Sorry, that's not true at all. If I'm in state A and I see a B, then it's undefined. So as drawn, this is currently a non-deterministic finite automaton. I could have also answered this question with a deterministic finite automaton simply by adding a trap state and sending all the undefined transitions there. So a B in this case, a in this case, and a C in this case. So just the black drawing by itself would be a non-deterministic finite automaton that solves the problem. With the red addition, this is now a deterministic finite automaton that solves the problem. And what makes it deterministic? Well, simply there's one and only one transition for every token for every state.